I see that some of the earlier recordings have a kind of a buzz in them in the background, which may be annoying. I'm sorry, but this is all recording from home, working from home, COVID, lockdown, etc. And there was a lawn mowing that was going on. Even though I'm on the 12th floor, the AC is turned on because AC spreads the virus. So you have to leave the window open. It's in Mumbai, very hot and humid. So all the noise comes in, right? So this is the life and teaching with COVID. Nonetheless, let's learn something that's very important for atmospheric circulation and ocean circulation, and is very uniquely related to a flow systems on a rotating framework. Okay, when you watch weather charts, for example, you may have noticed this is very common in the mid latitudes where people watch weather a lot. In the tropics, we don't have weather changing that much, but still people are watching more and more now to decide how to dress and whether to take an umbrella and so on and so forth. So this concept is called geostrophic wind. Okay, these are basically winds or currents where pressure gradient force is balancing the Coriolis force. So what does it look like on a weather chart? On a weather chart, you will see that actually winds are going along constant pressure lines. We kept saying that flow wants to go from high pressure to low pressure, and yet on weather charts, especially on the in the upper atmosphere, you will see that winds are actually going happily along constant pressure lines. How does it happen? It happens because the Coriolis is trying to force the flow to change direction because of the rotational effects, and the pressure gradient is creating a flow from high pressure to low pressure. So look at this cartoon I have drawn here. We are going from 1010 millibars to 980 millibars, which is a significant change, by the way. Could be a cyclone or a hurricane. So you have a parcel of air at high pressure, let's say between 1010 and 1000 millibars. It's going to want to start moving towards 980 millibars because the pressure gradient is going to make it flow down the gradient. But as soon as it starts moving, let's assume we are in the northern hemisphere, Coriolis is going to push it to the right? So it's going to deviate slightly to the right, and Coriolis is going to push it further to the right as it keeps moving along the pressure gradient. Eventually, you can have a situation where the pressure gradient force, which is obviously from high pressure to low pressure, shown here as PGF, or pressure gradient force, is in the opposite direction to Coriolis, which is pushing the air parcel to the right of the direction in which it is moving. So when these two forces can balance each other, you have a flow that's moving along constant pressure lines. Pressure gradient force is exactly balancing the Coriolis. What is important here then? We talked about the friction between winds and water and between layers of water and so on. There is no friction here. It's only the pressure gradient force and the Coriolis. Okay? So best way to remember it is on most places on Earth, in the atmosphere and in the ocean, there are places where friction can be small and Coriolis is a very strong constraint which produces geostrophic flow. Okay? Immediately you should bring up your concept, but Coriolis goes to zero at the equator, which means it's very hard to have geostrophic balance, pressure gradient and Coriolis balance on the equator or near the equator. Okay? So geostrophic winds and geostrophic currents can be very strong off the equator where Coriolis is not zero. So this is a concept that you should remember. Geostrophic flow, and next time you look at the weather charts and you see flow along constant pressure lines, you tell grandmother you're going to show her magic. And you ask her how flow should go, and she will say from high pressure to low pressure. Then you show her flow along constant pressure lines and say, aha, grandma, what happened? Why do we have flow happening along constant pressure lines? And then you explain to her this concept of geostrophy, and grandma is going to be very happy.